everyone, this is Team 1597 consisting of Rishabh Kumar and Varun Vashisht participating in the Texas Instruments Analog Design Contest 2014. Our project is Automatic Sound Detection and Direction of Device. Sound source localization remains as a challenging task due to many factors such as environmental noise and reverberation, as well as real-time calculation requirement. The applications of sound source localization algorithms can be found in many areas such as human-robot interaction and video conferencing. The method that we have used is direct method, in which a microphone array is steered to various locations and searches for the peak of the output power. The location with the highest output power is considered to be the sound source location. The problem can be modeled as follows. Sound source detection. To go as much miniaturization as possible as well as high sensitivity, we have used MEMS microphones. The next step is acoustic localization. This consists of determining the direction of the incoming sound signal in a horizontal plane consisting of the microphone. This involves the main circuit and will be explained later. The next step is directing microphone towards the direction. After successful detection of the direction of the sound source, the amplifying microphone is directed using a servo motor controlled to the exact degree by using a microcontroller. Hello. Here is a live demonstration of the project. The project consists of a box having windows on each side to let the sound sample come inside the box. Inside the box there is a constantly rotating microphone which collects the sound samples coming through the windows. As it moves in a circle, whenever the energy of the sound sample is greater than a certain threshold set by the user, it sends a signal to the microcontroller. The microcontroller, then controlling the main microphone, directs it towards the speaker. I'll show you another example. Hello. Hello. Yes. As you can see, when I spoke from this direction, the sound signals were coming through this window. The microcontroller controlling this microphone readily directed the microphone towards this direction. I'll show you another example. Now there is a limitation with this project. Throughout the project we are assuming that there is only one single sound source for the microphone to collect it. That means when I am speaking, when I am walking from one position to another, I cannot speak in the midway. Thank you. Now it is time to explain the acoustic localization which was featured in the problem model. The acoustic localization consists of a microphone which is constantly rotating in a plane with sufficient speed, collecting any sound available and transferring the signal to the filter. The output of the microphone is fed to the filter. The filter removes any DC environmental noise and passes the signal to the amplifier. The amplifier takes the previous output and amplifies the signal for processing. The processing, which is modeled here as a comparator, can consist of two variations, which we have tried. The first one is MATLAB. The signal can be operated upon by various signal processing techniques to determine the maximum energy among all directions. The output of this MATLAB program can be fed to the microcontroller by a USB. The second variation, which we have implemented more closely, is analog comparator. The output of the amplifier is fed to the analog comparator, which compares with an user adjusted level
to determine whether sound is present or not. As soon as the sound signal's direction is determined, the angle or direction is noted and fed to the microcontroller. The microcontroller, upon receiving the angle, drives the servo motor to rotate the main microphone, and the video conferencing completes itself.